Hello learners, welcome to Education Online program. I'm teacher Willa Lucia. So in our previous lesson, we looked at the equation of state, where we say that the equation of state expresses the relationship between the temperature, pressure, and volume of a gas. So today we shall be looking at the gas laws and the kinetic energy. Gas laws and the kinetic energy. So when we talk about the gas laws, we talk about the Boyle's law, the Charles law, and the pressure law. What of the kinetic energy? So you see that with the kinetic theory of matter, it states that matter is made up of tiny particles known as the molecules or the atoms, and they are in continuous movement. So if they're in continuous movement, meaning that they have a motion, that is random motion. So this random motion and the speed of the movement of the particles is directly proportional to the temperature. So we can say the kinetic theory of matter states that matter is made up of tiny particles that are in continuous random motion. Which is directly proportional to the temperature. So from our kinetic theory of matter, we mean that this random motion, the movement of these particles, their constant movement is due to the temperature. That means that these two they are in direct correspondence with each other. So when you look at the kinetic theory of matter, it considers that the molecules or the atoms of a body is elastic in nature. Why does it assume that these molecules are elastic? Because if you take a look at this, our molecules are, if we have this as our tiny molecules, you see that when these molecules here come into contact with the wall of a container, they do not come and just remain and stick around the wall of this container, but instead, after them hitting the wall, they will also move from this point to another. So they also continue moving. They do not remain at that same point. That's why the theory assumes that these particles are elastic in nature. So you see that these molecules here, when they also strike they strike the wall of a container, what happens is that there is a force that is produced. So this force here that that is due to the striking of this, or the collision of the wall of the container with the molecules of either the liquid or the gas, is what is known as the momentum change per seconds. So that is the force. The name of this force here is known as the momentum change per second. So it is written as gives us the force. So if we have it like that, how does the pressure in the liquid or the gases arise? So to know the causes of this the pressure in the gas, let's take a look at this. We have our container. Let me say that we are going to confine some gas. This is more like the piston. So we have, this is our piston. We have the gas here. Let me have it as a circle so that it can be visible. These are the molecules of the gas in the container. So what happens is that when these molecules come, they collide with one another. Since the kinetic theory is saying that they are in constant random motion. And remember, if they're in constant random motion, it's not like there is only one molecule in the container or the molecule of the gas. There are so many molecules that makes up that particle, the matter. So you see that this one will come and collides with this other molecule, and then it will move. It keeps on. This one will also collide with that, not only colliding in between them, but then they will also go ahead and collide with the walls of this container. So that force there gives rise to the pressure in the gas, because for it to move from there up to there and hits that, it does not just go slowly, but then there is a speed, a certain speed it attains so that it can reach and hits that. So it hits it with a lot with force, which is known as the momentum change, because when it hits here, it is going to bounce back. So meaning that when it was going, there was a velocity given to it, and then that molecule has got also the mass. So you see that when you're saying that our force, to get force, it is mass and then the acceleration there. So if it moves with if it is accelerated to the wall, it is going to produce this force, and this force here also gives rise to what is known as the gas or air pressure. So let me say it is the air, the causes of air pressure. So it is just because of this force we've been talking about. So you see that this kinetic theory of matter here can be used to explain the laws of gases, where we have the Boyle's law, the Charles law. But then how can we explain using this kinetic theory? So let's look at the Boyle's law. So if we have the Boyle's law, this one is saying that matter is made out of particles. And in this situation here, we are dealing with particles. But then in Boyle's law, it was stating that the volume of a fixed mass of a gas is inversely proportional to its pressure when the temperature is constant. So now, how do you explain this? Using kinetic theory of matter. So you'll see that at constant temperature, what happens to the molecules of a gas or a liquid? So you see that when the temperature is kept constant, that means that the pressure, the kinetic energy of your molecules remains constant too, because the kinetic energy varies with the temperature. So you'll see that at constant, when you keep the temperature constant, instead of these molecules expanding, what will happen is that the container, maybe you've confined it in a certain container, so when you're not heating it varying this temperature, since you are saying that our pressure is inversely proportional to the volume, if you try to increase the volume of this gas, what will happen? It will happen that these gases here will not have like a, when you increase the volume, the collision in between them is going to reduce, because increasing the volume of the gas means that this gas here will have a very there will be spaced. So for them to hit, to collide with another molecule, it is going to take time for them to go from their position and then collides with the other molecule. Even the walls of the container, to reach the walls of the container will take some time. So meaning that as you increase the volume of this gas, there will be less collision. And if there is less collision there, that means that you've reduced the force that it would have produced from the bombarding onto the wall and then onto other molecules of the gas. So if you reduce that force, what happens to pressure? Pressure is reduced, because this pressure rises from their collision. So what if now you reduce the volume? So reducing the volume means that there will be high collision between the molecules of the gas. So when the particles collide more, that means that there will be increase in the pressure. So that's why we are saying that with the Boyle's law, you find that the pressure is inversely proportional to the volume. So the bigger the volume, there will be less pressure. So to increase the pressure of the molecules, you'll have to reduce the volume of the gas. So that is how you use the kinetic theory to explain the Boyle's law. Now let us take a look at the Child's law. With the Child's law, we are saying that it is the pressure we keep constant. If we are keeping pressure constant, what do we vary there? We vary the temperature and the volume. And then this variation, they are directly proportional to each other. So you see that when the temperature of gas molecules is increased, let us take a look at this. Assuming this is we are having this gas here, so we're going to heat these molecules here. If we increase the heat, this is the temperature. what will happen to the molecules here? Remember, there are bonds here. They have attractive bonds in between them. So heating this, increasing the temperature of these molecules, is going to cause these bonds here to be broken. So if the bonds are broken, you'll have this moving at a higher speed, because there you have increased their kinetic energy. They move now from one point to another at a very high speed. So meaning that also you have expanded this gas. So when you expand this gas, there will be increase in the volume. So every time you increase the temperature, these molecules their kinetic energy will be increased. The bond in between them, the bonds of attraction, will be loosened. So meaning they are going to be moving faster. So if they expand, that means the volume is increased. But then how would you keep the pressure constant? Because here we say that we have to keep the pressure constant and then just varying the temperature and the volume with the Charles law. To keep the pressure constant, we shall have increased volume. So you see, when you increase the volume, that means that for them to collide also with one another, the molecules, it is going to take time, because they have to occupy a wider volume, a wider area. So if they are occupying a wider area, these molecules are going to be more spaced than they were together before increasing the temperature. So that is how you maintain the pressure of the gas constant when you're explaining the Charles law using the kinetic theory of matter. So we also have the Charles law, the pressure law. Pressure law states that, before we go to the statement, what do we keep constant? And pressure. In pressure law, we keep the volume constant. So you see, if you keep the volume constant, what do we vary? We vary the pressure and the temperature. So you'll see that the pressure law states that the pressure of a fixed mass of a gas is directly proportional to the temperature when the volume of the gas is kept constant. So you see, when you rise or increase the temperature of these molecules, increasing their temperature means that they are also increasing the kinetic energy of the molecules. So when you increase the kinetic energy, you see that these molecules collide more frequently. And when they collide more frequently, that means that there will be high pressure there, because you've increased the rate of change of momentum of these molecules per second. So if you increase their frequency of collision, means that you have also increased the temperature of these molecules. So when you decrease the rate of collision between the molecules, you're going to reduce the gas pressure, because as we said before, the gas pressure is caused by the bombarding of these molecules between amongst them and then the wall of the container. So you see that when you reduce the rate at which they bombard, meaning that there you have reduced the temperature. Because when you reduce the temperature, you're trying to strengthen the bond between these molecules. So the more you continue strengthening the bond, there will be less kinetic energy. And when the kinetic energy is reduced, their rate at which they collide, to move fast and collide with each other, is dropped. So that means that the rate of change of momentum between the molecules, or between the molecules and the wall of the container, is reduced, and that automatically reduces the pressure that the gas would exert. So that is the explanation of the pressure law using the kinetic theory of matter. Now, what about the effect of temperature on pressure? Let's look at the effect of temperature on pressure. How does temperature affect the pressure of a gas? Because here we are dealing with the gas laws. So you see that when you increase the temperature of a matter, of an object, what really happens to the pressure of that object? So you see that when any gas is heated, assuming this is the gas, we're going to have it in a flask. This is our flask containing the gas here. Let it be a dry gas. Why dry gas? Because if it is a moist, it is going to, when you increase the temperature of gas that is moist, what happens? It will escape as the steam. It will all change and escape outside. So you see that when you reduce, it will condense back to water instead of maintaining its state as the gas. That's why we are using the dry gas. So what happens if we have the gas molecules in the flask and we are increasing the pressure, the temperature of this gas? So as we've been saying continuously, increasing the temperature under any molecule, it is going to increase the kinetic energy. So when you increase the temperature, and then we're saying that the kinetic energy is also increased, what happens? These molecules will be moving at a very high rate. So moving at a very high rate means that the rate of collision between this will also increase, and then with the walls. So when it increases, you see that this one here, we assuming that is the molecule, it will come and collide with this. Since we say that kinetic theory assumes that the particles of matter are elastic, if this molecule comes and hits this, collides with this, it will not remain there. It will not stick to that. But then it will move and then comes and hits probably with another, collides with another molecule. This wall here has got particles too, But then it does not mean that when these molecules come, they will remain on the wall. No, because of their elastic nature, they will leave the walls of the surface of the flask, and then continue with their motion of collision. So when they continue with that, you see that when they continue with their motion, there will be increase in the force that is created in the flask. So when they increase this force, meaning that our pressure will be increased. But then if the container is flexible, you see that the volume of the gas increases in order to maintain the increased pressure. How does the volume also of the molecules increase? The molecules increase in a way that we said the temperature and molecules of a matter, it causes these molecules to expand. And we know that when something expands, that thing actually increases in size. So meaning that this gas here, when they expand due to the increase in temperature, they will increase in the volume. So when this container, when the flask containing the gas is actually flexible, it will expand so that it can contain the increase in the volume of the gas. But what if the flask is not flexible, or the container is not flexible? What will happen? So you see that if it is not flexible, the container will burst, or we can say it can break, because it is not in position to accommodate the increase in in the volume of the gas molecules. And then because of this frequent collision, it is more violent. So with increased temperature, it cannot accommodate all the pressure inside here. That's why you see that the container will burst. Let's take an example of a balloon. Because a balloon, you see, when you blow air inside the balloon, you confine the air there. You try to tie the balloon up so that the air does not escape. So there you had a fixed mass of the air inside the balloon. Why is it that when we blow the balloon, then we leave it under the sun, you will come and find that probably the balloon bursts? This is because of this theory here that causes the effect of temperature on pressure. You'll see that this is our balloon. So we tied it somewhere here so that we can maintain the amount, the mass of the air we blew inside it. So now when it is under the shade, it's having a different temperature there. But then take it under the sun, and you see what will happen is that the air you blew inside this balloon has got tiny particles. It is also a matter. So these tiny particles, they collide with each other. They do not just remain stuck like the particles in solids. The gases, the particles move from one point to another. So putting it under the sun increases the temperature around the balloon. But you're increasing this temperature. Remember, your balloon has a fixed volume there. So these molecules will keep on moving and colliding with each other, and then the wall of the balloon, they will continue like that. And the more the temperature increases, when the sun keeps on heating up, it is going to cause the kinetic energy of these molecules to increase. So it will make them collide violently and vigorously in the balloon. So when they collide violently, that means that the pressure they produce inside the balloon is too much, that the balloon cannot handle. So since the balloon is not flexible enough to expand and contain this the pressure increase in it, instead it will just burst. That's why you find sometimes when kids are playing, others will be saying, don't take my balloon under the sun, because of this theory behind it. When you increase the temperature, you increase the pressure inside the balloon, and the balloon will easily burst. So for today, this is what we are to know about the kinetic theory of matter. You should always remember that this matter have got tiny particles that are in constant random motion, and then their motion is proportional to the temperature. If you reduce the temperature, you reduce the rate at which these molecules move from one point to another. So with the temperature, as you increase the temperature of a body, you increase the pressure in between the molecules and the walls of the container. So with this, we come to the end of our lesson. We shall meet again in the next lesson. Thank you very much for attending.